In this video, we're going to cover the problems that were on your Unit 8 review. So you should have already tried these on your own. And if you want to check your answer, you can scroll through the video as much as you want. If you have a question about a specific answer or question, then you can scroll to that point and look at that work. I apologize, this is going to be a little bit long of a video because it's going to cover all of the review problems. And just as a reminder, Unit 8, the focus on Unit 8 was quadratics, but specifically the vertex form of a quadratic, dealing with inequalities of a quadratic, and the applications of quadratics. So let's go ahead and take a look at number 1. It says solve by completing the square. Now this is a review problem from the prior unit. So part A, it says x squared plus 18x equals negative 45, and we're trying to complete the square. Well, completing the square means we have to figure out the c value that we need to add to both sides so that this expression on the left here is a perfect square. In other words, the two factors that you get are the same two factors. So the way we do this is we set up our x, and in this case we don't know every x value or every bit of information here. We don't know what goes on top because even though we know what a is, we don't know what c is. But we do know that the b value is 18, so we can put that on the bottom. Because we're trying to make this a perfect square, we know that these two side things are going to be the same, and since they add up to 18, the two sides have to be 9 and 9. We're just going to divide 18 by 2 to get that. And then we multiply those two to get to the top number here, and we get 81. Well, that tells us that we're going to add 81 to both sides of this equation. So if I add 81 to the left, I'm going to add 81 to the right. Now I can go through the big long factoring process to factor the left-hand side, but the reality is I already did all my work, and since a is 1, my factors are just going to be x plus 9 and x plus 9. And then the negative 45 plus 81 is 36. Well, now I can write x plus 9 times x plus 9 as x plus 9 squared, and then to solve this, because I'm trying to solve by completing the square, it's already in that form. To do so, I just need to square root both sides. Remember, when you square root a squared, those will cancel each other out, so you're left with x plus 9. But when you square root a number, square root of 36, you always get two answers out. We get the positive and the negative version out. So the square root of 36 is plus or minus 6. And then to solve for x from here, we're going to subtract 9 from both sides. And so we get two answers. We have to ask ourselves what they are. What is positive 6 minus 9? And what is negative 6 minus 9? Well, positive 6 minus 9 is negative 3. And then negative 6 minus 9 is negative 15. And so those are our solutions for part A. For part B, it's going to be the same thing. We're going to complete the square. So we're going to set up our x values, the x thing. We're going to put negative 14 on the bottom because that's the b. These two things have to be the same, so it'll be negative 7, negative 7. The top will be 49 because those have to multiply to that, which means we're going to add 49 to both sides of our equation. Then we can write this side as a factored form of x minus 7 times x minus 7, or we can just say it's x minus 7 squared. So I just skipped that step. I skipped this step here. 79 plus 49 is 128, and then to solve this, we're going to square root both sides. So when I square root something, remember I get two answers, but in this case, in part A, the square root of 36 was just plus or minus 6. It was a nice whole perfect square. The square root of 128 isn't so clean. So we have two different methods to write this. We could write it as a simplified radical, or we could write it as a decimal. I'm going to walk through both of those with you. The simplified radical is going to be plus or minus 8 rad 2. We've done that in the past. I don't want to dwell on how to do that. We're going to add 7 to both sides. Now when I add 7, 8 rad 2 and 7 are not like terms because this has a rad 2 that I'm multiplying by and this doesn't. So we're just going to leave this as 7 plus or minus 8 rad 2. That's my answer in simplest radical form. If I want it in decimal form, well, I've got to figure out what the square root of 128 is. So I would just use my calculator. The square root of 128 is going to be 11.314, and then we add 7 to both sides. And again, we're going to get two distinct different answers here. What is positive 11.314 plus 7? And what is negative 11.314 plus 7? So our two answers are going to be 18.314 and negative 4.314. And so that's our second type of answer. So you got to read the problem and see which form it wants it in. if it doesn't have a clean square root. Going on to number 2 here, we're given a graph, and it tells us the equation of the function f of x equals 2x squared plus 8x plus 3, and it gives us that. Okay, it gives us the equation in the graph. It says, what is the domain of the function? Well, a parabola always has the same domain unless something special is going on here. The domain is going to be from negative infinity to infinity, so we just write that as negative infinity, less than x, less than infinity. The next question says, what is the range? Now remember, the range is the set of y values. So what I like to do is I like to draw a horizontal line at the point where the parabola stops going up or down. So you can see that the lowest that this parabola gets is this dotted line. Now how high does the parabola get? The parabola goes on forever up, so there is no bound up there, so I can't put a dotted line up there. But what is the lowest y value? The lowest y value is going to be negative 5. That's how low this parabola goes. So we'd say the domain is from negative 5 to infinity. And so notice I shaded in, I colored in the part of the graph where you see the parabola. You see the parabola above the dotted line. So every y value from here up is your domain. So from negative 5 less than or equal to y less than infinity. The reason it's less than or equal to is because this parabola actually does touch negative 5. For the next question, it says what interval is the parabola decreasing? Well, we're going to cut the parabola different this time. We're going to cut the parabola along the axis of symmetry. Now, which side of the axis of symmetry do you see the parabola decreasing or going downhill? You can see the parabola decreasing on this side. This part of the parabola you can see is decreasing because remember we always read left to right. So I'm going to shade in that side of the line just like I did before. Well, what are the x values of that side of the line? Well, it goes back to negative infinity and it goes forward to negative 2. So we'd say negative infinity less than x less than or equal to negative 2. For D is a different type of question. We've had this is a review problem. It says, what is the average slope over the interval negative 3 less than or equal to x less than or equal to negative 1? Well, what I need to do first is recognize that negative 3 is an x value, and I need to figure out the y value of that coordinate. So basically what I'm saying is, I've got this coordinate negative 3 comma something of that parabola. What is that something? Well, if I go back 3, where's the parabola at? The parabola is down here, so we went down 3 there. So that coordinate is negative 3 comma negative 3. You can see it right here. I put a little dot there. The other coordinate has an x value of negative 1, so it'll be negative 1 comma something. So where is that on the graph? Well, that's negative 1 comma negative 2. I went down 2 there. So our coordinate is negative 1 comma negative 2. And from here, we're just looking for the slope between those 2 points. Well, that's easy enough. Remember, slope is rise over run. So you went up 1 and then right 2. So our slope would be 1 over 2. Okay? Now, we can do that using the slope formula. Remember, the slope formula is y2 minus y1 over x2 minus x1. And we can use the coordinates that are given here to show that work. Well, y2 would be negative 2 and y1 would be negative 3. So it would be negative 2 minus negative 3. And then all over negative 1 minus negative 3. Well, negative 2 minus negative 3 is actually negative 2 plus 3, and then negative 1 plus 3 on the bottom. Negative 2 plus 3 is 1, and negative 1 plus 3 is 2. So you can see the slope that way as well, but the bottom line is the slope is 1/2. For part E, it says if a line passes through on the graph g of x equals 2x plus 3, for what x values does f equal g? Now this problem is a review problem from the last unit, but it's an important one. So we have this parabola, and then we also have this line, 2x plus 3. So let me go ahead and graph that line. That line has a y-intercept of 3, so I'm going to put a dot there. And then it has a slope of 2, so that means I'm going to go up 2 over 1, and then up 2 over 1, up 2 over 1. I could also go down 2 and back 1, down 2 and back 1, and so on and so forth. And so I end up with this, this line. The question here says if the line passes through, okay, the line passes through this parabola, at what x values? Well, we can see that it passes through the parabola at this point and at this point. So what are those x values? Well, those x values are x equals negative 3 and x equals 0. So those are our two answers there. Okay. Going on to number 3, again we have a graph with a line intersecting it. It says, what is the axis of symmetry, AOS? Axis of symmetry, we're talking about the parabola here. Well, the axis of symmetry is the line for which the parabola reflects upon itself. And remember, we always write it as x equals. So in this case, it would be x equals -2. What is the vertex? The vertex is the point where the parabola changes direction. So it's going to be -2, comma, whatever that y value is, that's 4. So -2, comma 4. Now it's asking for what the x-intercepts are. Well, the x-intercepts are where the parabola crosses the x-axis. So it's going to be -4, 0 and 0, 0. We can see those 2 points there. -4, 0 and 0, 0. Remember, the format for which you write these things is important. If it's an x-intercept, it should be a coordinate. It shouldn't just be numbers. -4, 0 and 0, 0. Now it's asking for the domain. Well, the domain is the same on every parabola, so it's -infinity, less than x, less than infinity. And I'm going to go ahead and skip the range for a second. I want to go down to h, where it says on what interval is the graph decreasing, because again, the decreasing is dependent on the axis of symmetry, and I already have that written. So which side of the axis of symmetry is the parabola decreasing? Well, it's going down on this side, so I'm going to highlight that. Oh, no, sorry, G is asking for which side of the parabola is the graph increasing. So this part's increasing, so that's from -infinity all the way to -2. Okay, so on that side, -infinity, less than x, less than or equal to -2. And then now for the decreasing part is this side of the parabola. So we'll use purple there. So this side of the axis of symmetry is the interval for which the graph is decreasing. So that's from -2 is less than or equal to x is less than infinity. And so now let's go ahead and go back up to F, the range. The range is what is the lowest that this parabola goes and what is the highest. Well, remember in the previous problem I drew a horizontal line where the parabola stopped going up or down. So I'm going to draw a horizontal line up here because that's the highest point that the parabola got. Well, what part of this graph? Should I be above that line or below that line? Well, the answer is below that line. So what is that domain? What's the lowest? The lowest is -infinity, and the highest is whatever that line is. So it's going to be from -infinity, less than y, less than or equal to 4. Notice the only time you have y in an interval is in the range. Everything else is x values. All right, part I is asking for the average slope again. So we have to ask ourselves what the coordinates are. When x equals -2, the y value is, when x equals -2, the y value is 4. Okay? When x equals 0, okay, the y value is going to be, in this case, 0. And so we're just going to find the slope between those 2 points. Remember, it's rise over run, so in this case it's down 1, 2, 3, 4, so down 4, and then to the right 2, so right 2, so we'd say -4 over 2, and that simplifies to -2. So our average slope is -2. And then for J, it says at what x values are the two functions equal? Just like the previous problem, except it gave us the graph here, we can see that the parabola and the line are equal to each other at these 2 points of intersection. Well, what is the x value? The x value is -3, and the other x value is 0. So that wraps up number 3. Let's go ahead and go on to number 4. It says put the following in standard form. These are pretty basic. These are pretty straightforward. To put it in standard form, remember standard form is y equals ax squared plus bx plus c. So what we need to do first is we need to expand our square. So we're going to expand that to say x plus 5 times x plus 5. And then we're going to multiply those two binomials first. Don't deal with the negative yet. Just multiply the two binomials. So when I multiply that, I end up with x times x is x squared. I end up with x times 5, which is 5x. I multiply the 5 and the x and I get 5x, and I multiply the 5 and the 5 and I get 25. Now notice there is something outside those parentheses. There's a negative outside, so I still have to deal with that. So I'm going to put parentheses around everything that I just got and put the negative out there. And then I still have this minus 16 at the end. Now I'm going to go ahead and distribute that negative value into all of those things. So I end up with negative x squared minus 5x minus 25, and then minus 16. And then I can just combine like terms from that. So I get negative x squared minus 10x minus 41. We're going to repeat that same process in part B. I'm going to go a little bit quicker here. You're going to get 2 times x minus 3 times x minus 3 plus 12. When I multiply all of that out, I get x squared minus 3x plus 9. And then I still have to multiply it by that 2 in front. So I'm going to multiply that by 2. I get 2x squared minus 6x plus 18, and then the plus 12. Combining like terms, you get y equals 2x squared minus 12x plus 30. We've had a lot of practice with converting things to standard form, so that should be pretty easy. Looking at number 5, this is going the other way. It's asking us to take standard form and put it into vertex form. Now remember, this is vertex form in number 4. So vertex form, remember, was y equals a times x minus h squared plus k. So vertex form implies that we need to find the vertex. Well, to do that, we have to find the axis of symmetry. And to find the axis of symmetry, remember, it's x equals negative b over 2a. So that'll be x equals negative 2 over 2 times negative 1. And that'll simplify to 2 over negative 2, or negative 1. And then we have to take this x value and plug it in to find the y value so we can find the vertex. So we would say y equals negative, and then in parentheses, negative 1 squared, minus 2 times negative 1 plus 15. Remember, the first thing we have to do here is the exponent, so it's negative 1 squared, not negative times negative 1, but negative 1 squared. So we get 1 there. Now we'll do our multiplication. So negative times 1, or negative 1 times 1 is negative 1, and then plus 2 plus 15. That simplifies to 16. So our vertex is going to be negative 1 comma 16. Negative 1 comma 16. From here, we're going to plug it into our vertex form. And again, our vertex form is a times x minus h squared plus k. And h and k are our vertex. So we would say, and then the a value here is the same as the a value that I started with. So the a value is negative 1. So we would say y equals negative 1 times x, let's see here, minus h, it says. Minus h implies that I'm changing the sign of my h value. I'm changing the sign here, so it'll be x plus 1 squared. And because this is a plus k, I'm not changing the y value, so it's just plus 16. And that is my answer for part A. For part B, we're going to go through the same process. Find your axis of symmetry. X equals negative 8 over 2 times 2. That's going to be 8 over 4, which is 2. Plug that into our equation. So 2 times 2 squared minus 8 times 2 plus 8. Do the squaring first, so 2 squared is 4. Then do your multiplication, so 8 minus 16 plus 8, and then combine like terms, so you get 0 here. So plugging that in, my vertex is going to be 2 comma 0. Plugging that into my vertex form, my a value is 2 because it was there before, so y equals 2 times, and then it's going to be x. In this case, it's going to be, let's see, minus h, so we change the sign here, so it'll be minus 2, and then plus 0. Well, we don't actually have to put the plus 0 there, we can erase that, so because adding 0 doesn't change anything. So we can write it like this. If you want to put the plus 0 at the end, that is okay too. So that's number 5. Number 6, it says consider the parent function f of x equals x squared. Complete the equation g of x that would produce a graph of the parent function that is shrunk vertically by a factor of 1/3 and is translated 6 units right and 4 units down. So we're writing vertex form again. Remember, vertex form is a times x minus h squared plus k. Our goal is to identify what a, h, and k are. So remember, a is our vertical shrink or our vertical stretch, and it's also dealing with the reflection, whether the parabola opens up or down. Well, here it doesn't talk about a reflection, so we know that a is going to be positive. It says that it's vertically shrunk by a factor of 1/3, so that means a is 1/3. And then it is translated 6 units to the right, so that implies that h is positive 6 because we're moving in the positive direction. And then it says translated 4 units down, so that means k is negative 4 because we're going down. And then when we plug that into our vertex form, we get 1/3 x, and then it's going to be minus h, so it'll be minus 6 squared, and then minus 4. Remember, you change the sign of your h and put that there, and you keep the sign of your k and put it there. For the second one, again, it doesn't talk about a reflection at all, so we know a is positive. It says that we are vertically stretching by a factor of 2, so that means a is 2. And we're translating 3 units left, so that means h is -3. And 7 units up, so k is +7. And so our vertex form would be y equals, or g of x equals, 2 times x plus 3 squared plus 7. Again, noting that I take my h value, which is -3, and change the sign, and then I keep the k sign the same. So that's number 6. For number 7, it says describe the transformation that maps the parent function onto h of x. Okay, so we're doing exactly the opposite here. We have the vertex form, and we're asked to write a sentence about what the transformation is. So we're going to start off with the a value. The a value is negative. Well, if the a value is negative, that means we have a reflection about the x-axis. So we'd say x squared is reflected about the x-axis, okay, or across the x-axis. Now notice that a is -1, so there is no stretch or shrink. And now we'll go into our translation. Well, because that says +2, remember we changed the signs of this one, so we're actually moving to the left, we're moving back 2. So we'd say translated 2 units to the left. And then the last part it says +6, so we keep that sign. So we're translating 6 units up. All right, the next part of this, it says graph h of x on the coordinate plane. So this is pretty straightforward. Remember, the two things you need to graph a parabola are the vertex, and in this case the vertex is going to be -2, 6, because again we're changing this sign and we're keeping that sign, and we can see that here, 2 units left, 6 units up. And then we need our slope pattern. Remember, our standard slope pattern is 1, 3, 5, but we take our slope pattern and multiply it by our a value, and our a value is -1. So we're going to say -1 times 1, 3, 5, 7, 9, 11, so on. And so we end up with -1, -3, -5. So starting off at our vertex, we're going to go back 2 and up 6, so we end up with a point here. And then from here we're going to go down 1 to the right 1, because it says negative, we're going down. So down 1, right 1, and then down 3, right 1, and then down 5, right 1. And so we get those points. And we do the same thing on the other side, the reflection. And then we do our best at drawing an accurate parabola from there. Remember to represent all the points that you can in the graph from your slope pattern. For number 8, it's the same type of thing. It says describe the transformation that maps the parent function onto g of x. This case, you notice that it doesn't have x plus or minus something squared. It's just x squared. So that means we don't have any shift to the left or the right. Well, first thing again, remember the a value. The a value is going to be 1/2. And then I'm going to rewrite this so it's a little bit more familiar. So it's going to say 1/2 x plus or minus 0 squared, and then -2. So this is equivalent to this guy, because x minus 0 is just x, and then we're squaring it. So if you see something like this, it might be a good idea to write it like that first. So now let's describe the transformation. We have a vertical shrink by a factor of 1/2, and notice there is no reflection here because the a value is not negative. We have a translation. It's not moving left or right, but it is moving 2 units down. So, and translated 2 units down. All right, from here we're just going to graph this. So that means our vertex is 0, -2. And then our slope pattern, remember our slope pattern, we're going to multiply by the a value. So in this case we're going to multiply 1, 3, 5, 7, 9, and so on by 1/2. And so when I get that, I'm going to put this in decimal form. I think it's a little bit easier to comprehend here. 1/2 times 1 is 0.5, 1/2 times 3 is 1.5, and 1/2 times 5 is 2.5. And then you can extrapolate from there. It should be 3.5, 4.5, and so on. So starting at my vertex 0, -2, here's my point. From here, I'm going to go up 0.5 and over 1. I don't want you to think of this as up 1 over 2. You always move over 1, so it's up 1/2 over 1. Okay, that's the first point. And then from there we're going to go up 1.5. So we're going to go up, well, half is to the line, and then another 1. This is 1.5 to this point, and then over 1. And then from there we're going to go up 2.5 over 1. The next one would be 3.5 over 1. So there's the half. 3 more puts me right here. And then so on. We do the same thing with the reflection on the other side and then graph our parabola. And so we can see the graph there if the a value is 1/2. For number 9, it says write the quadratic in standard form with the given information. Well, this is dealing with the x-intercepts. It says the x-intercepts are 5, 0 and -1, 0. And then it has a vertical stretch of 2. So we can see that it has it gives us our a value. So we can say that, remember, if the x-intercepts are 5, 0 and -1, 0, that means that our factors are going to be the opposites of those. So that means our factors are going to be x minus 5 and x plus 1. That's just working with finding x-intercepts, but kind of going backwards here. So we know that those two things are the factors, and then we also know that the a value must be 2. Actually, I've got to change that because I didn't see the facts that it was a reflection. The fact that it was a reflection implies that a is going to be negative there. Okay, so then our final answer, not our final answer, but our expression is going to be y equals, let me fix that because I did not express that negative there. So it's going to be y equals -2 times x minus 5 times x plus 1. And then from there, we're going to go ahead and distribute the x minus 5 and the x plus 1. X squared plus x minus 5x minus 5. And again, keep in mind we've done plenty of practice with this. So if you need help multiplying binomials, you're going to have to ask me separately. And I've done plenty of examples here. So here I'm going to multiply, I'm going to distribute the -2 here. And I apologize for all of these because technically all these signs are wrong, because I did not see that reflection. So let me fix that real fast. That's going to be -2x squared. That's going to be -2x. This is going to be plus 10x, and this will be plus 10. And then combining like terms there, we're going to end up with y equals, let me fix this completely. This just makes sense to do that. Okay, so we're going to end up with y equals -2, -2 x squared, and then it'll be plus 8x, and then it'll be plus 10. Okay, so that's our answer for number 9. For number 10, it says write an equation of a function that has a point at -9, 0 and the vertex at -4, -75. Now notice here in part A, I gave you the two x-intercepts, and we'll see another example of this in a minute. But in this case, I only gave you one of them, but I did give you the vertex. And whenever you are given the vertex, it's easiest to start off writing things in vertex form. So remember, the vertex form is y equals a times x minus h squared plus k. And because I know that -4 is my x value, remember I changed that so it'll say x plus 4 squared. And then since my y value is -75, that means it's going to say -75. So that's my vertex form. The only thing I'm missing here is the a value. Well, to find the a value, all I have to do is plug this coordinate in to x and y here. So since -9 is the x and 0 is the y, this will say 0 equals a times -9 plus 4 squared minus 75. Then we're going to do our order of operations, so we're going to do our parentheses first, so it'll be -9 plus 4, which is -5. And then we're going to square, we're going to do our exponent, so -5 squared is positive 25. Then we'll add 75 to solve for a, and then we'll divide by 25 and get a equals 3. So our complete vertex form is y equals 3 times x plus 4 squared minus 75. And then because it said write it in standard form, we've got to expand all that and multiply it out and combine like terms. We did an example, a few examples of this earlier on, so I'm going to skip that step. Your final answer is going to be y equals 3x squared plus 24x minus 27. All right, for part C, Here's another example of given the x-intercepts. So since I've given the x-intercepts of negative 6, 0 and 4, 0, that tells us that our factors are going to be x plus 6 and x minus 4. And then we look and it says that we are vertically shrunk by a factor of 1/2, and there is no reflection, so that means A is going to be 1/2. And so we can just plug this in. We're going to get y equals 1/2 times x plus 6 times x minus 4. And then we'll simplify that to put that in standard form. So we're going to multiply the x plus 6 and the x minus 4. And we end up with that. And then we have to multiply all that by 1/2. So we'd end up with 1/2 x squared. And then 1/2 times negative 4x is negative 2x. And 1/2 times 6x is 3x. And then half of negative 24 is negative 12. Combine like terms, so you end up with y equals 1/2 x squared plus x minus 12. For part D, write the equation of the function that has a point negative 2, 4 and the vertex at 1, 8.5. So this is just like part B. Start off with your vertex form, so it would say y equals a times x minus 1, because remember change the sign, squared, and then plus 8.5. Now we're going to plug this coordinate in, so we're going to plug in 4 for y and negative 2 for x. And then we're going to simplify that, so negative 2 minus 1 is negative 3. We square that guy, we get 9a there. Here we're going to subtract 8.5, so we end up with negative 4.5. And then we're going to divide by 9. Well, negative 4.5 divided by 9 is actually negative 1/2, or negative 0.5. Plugging that into the vertex form, we get y equals negative 1/2 x minus 1 squared. Oops, got another issue here with my negatives. Negative 1/2 x minus 1 squared plus 8.5. Then we're going to expand all that. And then when I expand all that, I got x squared minus x plus 1. Multiply that by the negative 1/2 out front. So you end up with negative 1/2 x squared plus 1/2 x plus, oops, let me take a step back here, plus 1/2 x minus 1/2 minus 8.5. And then combining like terms there, we end up with negative 1/2 x squared plus x minus 9. So that is part D. Going on to number 10, it gives us an equation of y equals negative 2x squared plus 8x plus 1. We're looking for the axis of symmetry, so remember that's x equals negative b over 2a. Simplifying that, we end up with positive 2. Then for part B, so our final answer there is x equals 2. Make sure you have it in that notation. Don't just say 2, it's x equals 2. For part B, we're going to take our axis of symmetry and plug it back into our equation. We're going to simplify that by squaring first, then multiplying, and then combining like terms. So our vertex is 2, 9. And then remember for our y-intercept is actually this last number, but because it's a y-intercept, it's a coordinate, so we have to write that as a coordinate. What is the x value? The x value is 0, and the y value is 1, so our y-intercept is 0, 1. And then for part D, it says, what are the x-intercepts? Show all your work. Well, how do you find x-intercepts? X-intercepts are when y equals 0. So the first step in this is to say 0 equals negative 2x squared plus 8x plus 1. And then from here, we'll solve. I will just note here that if you try factoring, it's not going to work. So we have to revert to maybe the quadratic formula or some other method. So the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then simplifying all that, remember, you can simplify the inside of that quadratic by saying 8 squared is 64, and then negative 4 times negative 2 times 1 is positive 8. We can simplify the denominator to negative 4. And then combining like terms inside the radical, you got 72. And then because I'm looking for an actual x-intercept, I'm going to go ahead and put this in decimal form. So the square root of 72 is 8.485. And then we're going to get our two cases. Remember the plus or the minus. So what I did here is I said negative 8 divided by negative 4 is positive 2. And then 8.485 divided by negative 4 is 2.121. So we have 2 plus or minus 2.121, which is going to be 4.121. And the other option is going to be negative 0.121. So our x-intercepts, again, are coordinates. So it's going to say 4.121 comma 0 and negative 0.121 comma 0. Now we can take all this information and graph it pretty accurately. You have a vertex of 2 comma 9 here. We can follow our slope pattern perfectly. So our slope pattern is negative 2, so it'll be 135 times negative 2, so it'll be down 2 over 1, down 6 over 1, and then down 10 over 1. And do the same thing on the other side. We can check to make sure we're accurate because our y-intercept is 0, 1, just like it should be. And then our x-intercepts, if we draw this accurately, we notice that our first x-intercept is like just below 0, so negative 0.121, and then another one that's just above 4, so 4.121, so we got it right there. For number 11, it says that we are given the parent function x squared is the dotted line, and then we have this parabola here and we're trying to figure out the transformation. Well, the first thing we note is that our parabola is upside down, so that means we have a reflection about the x-axis, so we'd say x squared is reflected about the x-axis. The next thing we would say is our vertical stretch or shrink. Well, remember that's based on the first movement. So the first movement from the vertex is down 2 over 1, so that means we have a vertical stretch by a factor of 2. Okay. Because our normal slope pattern is 135, but in this case our first movement was 2, not 1. And then we have to talk about our translation. Well, we translated 5 units to the right and 7 units up. So translated 5 units right and 7 units up. Now, for part B, it says use the vertex and the point to determine the value of A. Now we've done a couple of these already. If you take the vertex was, let's see, the vertex here was 5 comma 7. And so when I plug the vertex into my vertex form, I'm going to get x minus 5 squared plus 7. We're trying to figure out the a value, so we're going to take the other point that I have, the 6 comma 5, and plug that into x and y. So we get 5 equals a times 6 minus 5 squared plus 7. And then simplifying this, 6 minus 5 is 1. And then 1 squared is 1, so we're just left with a there. We'll subtract 7 and end up with negative 2, so a is negative 2. And then from here it says write g of x in vertex form, so that's basically this with plugging in the a value of negative 2. So y equals negative 2 times x minus 5 squared plus 7. And then in part D it says write in standard form, so you would expand all that out. We've done this plenty of times. Multiply, combine like terms, and you'll have it in standard form. So I'm not going to dwell on that when I multiply it all out. So our final answer is negative 2x squared plus 20x minus 43 for number 11. For number 12, we're going to be doing the same exact thing. We notice that we have a reflection about the x-axis because the parabola opens down. Now the stretch is a little bit more difficult to see here. I identified 2 points here, one here and then one there. We can see that the first movement is down 3 over 1, so it's a vertical stretch by a factor of 3. And then we have a translation of 5 units to the left and 3 units up. All right, so there's our description. And then for part B, use the vertex and the point. So we're talking about this point here to find the value of a. So our vertex was negative 5 comma 3. So we'd start with y equals a times x plus 5 squared, and then plus 3, plugging our vertex in. And then we're going to plug this coordinate in. This coordinate was negative 7 comma negative 9. We're going to plug that into x and y, and then simplify all of that. So negative 7 plus 5 is negative 2. Then when we square the negative 2, we end up with 4, so we got 4a. And then we'll subtract the 3 from both sides, so we got negative 12. And then divide by 4, so you get negative 3. And then for part C, we're just going to take our a value and plug it in. And so our vertex form is g of x equals negative 3 times x plus 5 squared plus 3. And then standard form, I'm not going to go through all that work. The final answer is negative 3. Ooh, where did I get that from? Negative 3 x squared minus 30x minus 72. And so that's the answer for number 12. For number 13 is going way back in time to trigonometry. This is going to be an essential thing in Math 3. So we need to make sure we remember this. We're looking for the height of the tree. Well, the height of the tree, we're going to put an H there. H represents the height of the tree. We're going to do a review of trig. Well, how do I find the height of the tree? That's going to depend on the angle here. So based on this angle, we can see that the H is opposite to that angle. Remember, this only works, trig here only works with right triangles. So we have to identify the fact that this is a right triangle, and it is because we assume the tree is growing straight up. So H is our opposite side, and 57 is our adjacent side. So if you remember SOHCAHTOA, the acronym when you have the O and the A is actually tangent. So it's going to be tangent of 30 equals the opposite, which is H, over the adjacent, which is 57. From here, we'll plug into our calculator the tangent of 30, which is 0.577. And then we'll put that over 1 and cross multiply. So 0.577 times 57 is 32.909. And then H times 1 is just H. And so our final answer is 32.909 feet, or about 33 feet. For part B, it's the same thing. You got the height. In fact, everything's in the same position. So the height is the opposite. The 62 is the adjacent. And so it's going to be tangent of 42 equals H over 62. And then here I did this a little bit differently. Instead of figuring out what tangent of 42 is first, I put it over 1 and then cross multiplied. So you'd end up with 62 times whatever the tangent of 42 is equals H. And then from here, type in your calculator. So the tangent of 42 is whatever value, and then multiply that by 62, and you end up with 55.825 feet. Okay, for number 14, here we have an application problem. It says the height of a baseball that was hit by a batter is represented by h of t equals negative 16t squared plus 64t plus 3, where h represents the height of the ball and t represents the time the ball was in the air. So we can see here that we have a parabola, and that makes sense. A ball is going to go up into the air, it's going to go up into the air, and then it's going to come back down. Well, we understand that based on the equation because we see that the a value is negative, which means the parabola opens down. So up and then down. Now remember, there's different parts of a parabola. Let me go ahead and graph a quick parabola here. Okay, there's different parts of the parabola. There's the vertex, there's the, let's see here, poor drawing, you have the y-intercept, you have your x-intercept, right? And so you have all these different attributes. Now the reason I didn't draw the other x-intercept here is because this point is the moment that the ball was hit. This is the moment that time began, because it says the ball, let's see, it says that t represents the time the ball was in the air. Well, the ball was in the air from the moment it was hit until it hit the ground. So understanding how all these parts of the parabola are represented in these questions. So in part A, it says, what was the height of the ball when it was hit? So you just have to ask yourself, which part of the parabola represents when it was hit? Well, it's the initial height. It's right here. So it's the y-intercept. So we can see that the y-intercept is 3 here. So we'd say that the initial height, or the height that the ball was when it was hit, is 3 feet, because we're measured in, oh, it doesn't actually say, but it should say, where h represents the height of the ball, and it should say in feet, so 3 feet. Part B, it says, what is the maximum height of the ball? Well, where's the maximum height? The maximum height is up here. What's that? That's the vertex. So you just got to find the vertex here. So we'll find the axis of symmetry. So x equals negative b over 2a. And then we're going to simplify that. So we end up with t equals 2. And then we're going to plug that in to the function. So h of 2 equals negative 16 times 2 squared plus 64 times 2 plus 3. And then simplify all of that by squaring first, multiplying second, and then combining like terms. So we can see that we have a vertex of 2, 67. 2 is the x value. In other words, it's this axis. That is your t value, or your t-axis, you could say. That's your t-axis. And then this is your h-axis. So the first coordinate tells us how much time it took. The second value tells us how high it is. So we would say that the maximum height is 67 feet. And then we could add to that, we could say that the maximum height occurs 2 seconds after the ball was hit, or whatever the units of time are. It didn't say in this problem. So the maximum height is 67 feet. Part C, it says, how long was the ball in the air? Well, how long was the ball in the air? It was in the air from here to there. So what are we finding here? We're finding the x-intercepts. How do I do that? I set the function equal to 0. So I'd say 0 equals negative 16t squared plus 64t plus 3. From here, this is going to be a quadratic formula type of solution. So I'm going to just plug my values into the quadratic formula and then simplify from there. And again, I'm not going to dwell on this very long, and we want this in decimal form. So we get two different answers, the negative 0.046 and 4.046. Remember, we don't care about the first point because time started at 0. So the negative 0.046 is over here. We're going to disregard that. That is called an extraneous solution, which means it's a solution that doesn't fit the parameters of the problem or the real life scenario. So we would say that the ball was in the air for 4.04 seconds after it was hit. Part D, it says, at what interval was the baseball above 51 feet? Now this is an advanced level problem. So if you're one of those high achieving students, you might want to try this one. But basically what we're saying is, at what interval was the baseball above 51 feet? So let's say that this line represented 51 feet. We're looking for the part of the parabola that is above that. So it's just like the inequalities that we've been dealing with. You're going to set the function equal to 51, and then you're going to solve that and create an inequality. In this case, it actually works out pretty perfectly. It's from t equals 1 to t equals 3. But I'm not going to dwell on solving that problem. If you need more practice with that, you can go back and look at your examples that we did the other day. For 15, we have the same type of problem. You've got an equation that represents the height of a ball. Keeping in mind, we didn't talk about this in the last problem, but the negative 16 is the force of gravity. It's negative because it's pulling us down to Earth. The 48 is the velocity that the ball was initially hit at, and then the 6 is the initial height. So what was the height of the ball when it was hit? That's going to be the y-intercept, so that's 6 feet. What is the maximum height of the ball? Well, that's going to be the vertex. So solving the vertex, you notice that the vertex was 1.5, 42, so the maximum height is 42 feet, and it reached its maximum height 1.5 seconds after it was hit. Part C, it says, how long was the ball in the air? Well, the ball was in the air. You solve that by finding the x-intercepts. And so the second x-intercept was 3.120, so we say 3.12 seconds after it was hit. That's how long it was in the air. And then part D, when is it above 38 feet? That's going to be between 1 second and 2 seconds. I'm not going to go over that. You can ask me about these if you need additional help in our tutoring hours. For part 16, number 16, it says solve these graphically. So this one's actually pretty easy. It says let h of x equal x squared plus 2 and f of x equal x plus 4. So we need to graph this. Well, we notice that we have a y-intercept of 2, and this is just a parabola that's shifted up 2, and then we follow our slope pattern of 1, 3, 5. For the x plus 4, that's a line, so we're going to go up 4, that's my y-intercept, and a slope of 1, so up 1 over 1, up 1 over 1, and so on. So we have the parabola and we have the line. It's very important that you know how to graph a parabola and a line. For part B, it says, for what value of x does h equal f? In other words, when do these two things intersect each other? When do they equal each other? Well, the x values, it's asking for the x values, are going to be when x equals -1 and x equals 2. For part B, it's going to be the same thing, but I notice that h of x is written in standard form. That is a parabola again, but it's written in standard form. So we got to find the vertex. So we'll set x equal -b over 2a, figure out that value, plug that in to find our y value, and then simplify that. So we end up with 2 comma -1 for our vertex. And then our slope pattern again, because a is 1, is just 1, 3, 5. So there's my parabola. And then I have a line of negative 3x plus 3, so I'm going to start up 3. And then my slope is down 3, right 1, down 3, right 1. And then we ask ourselves for part B, where do they intersect? We can see that they intersect at this point and this point, so that's when x equals 0 and x equals 1. All right, that wraps up number 16. Last problems here. Solve the quadratic inequality. Draw a quick sketch to help write the interval. We did a bunch of practice just the other day on this, so if you need more review, go back and watch that video. But here, remember, we have to treat it like it's equal to each other, even though it's an inequality. We're going to subtract 6 from both sides, so we have the quadratic equal to 0. So we get x squared plus 3x minus 18. We're going to go ahead and factor this, and I'm going to skip that process. If you need more help, go back and watch that other video. And then we're going to set each of these factors equal to 0, so x plus 6 equals 0, and x minus 3 equals 0, and then solve each of these separately, so you get x equals negative 6 and x equals 3. Then we have this parabola here. This parabola opens up because the a value is positive. And then we have this line representing 6. Well, what part of that region do I want? I want the part that is greater than the line, so I want the part above the line, so I want that part. Well, how many pieces of that parabola are in that upper part? There's 2 pieces. The first piece is from negative infinity to negative 6. So we'd say negative infinity less than x less than negative 6. And the second part is 3 is less than x is less than infinity. And again, we don't put the equal signs here because the original didn't have the equal sign. For part B, it's the same thing. We're going to treat it as if they are equal to each other. We're going to solve for 0. So we get 3x squared minus 16x minus 12 equals 0. We're going to factor. So going through this process, because a is not 1, this one's a little bit harder to factor. A times c is negative 36, b is negative 16. Those are going to be negative 18 and 2. We're going to go ahead and expand this, so I'm going to show the work on this factoring. So remember the negative 18 and the 2 replace the negative 16 because they add up to that. Then we'll do our grouping. So the GCF out of 3x squared and negative 18x is 3x. And what's left over is x minus 6. The GCF out of 2x minus 12 is 2. So we got 2 times x minus 6. And therefore our factors are going to be 3x plus 2 and x minus 6. Set each of those equal to 0. And then solve each one of those. So you end up with x equals negative 2/3. And then x equals 6. So looking at this parabola, we see the parabola is opening up again. And then we have our line. We're looking for the part of the parabola that is greater than 5, so above 5. So we're looking for that upper part. Again, it's 2 pieces. So it's from negative infinity, less than x, less than or equal to negative 2/3, and 6 less than or equal to x is less than infinity. And because that's an equal sign in the original problem, that's why we have the equal sign on the negative 2/3 and the equal sign on the 6. All right, that wraps up your review for Unit 8. The next step in this is to actually take the Unit 8 test. So make sure if you have any questions that you log in for the office hours tutoring through Zoom so you can ask those before the test. The test will be on Friday, so please make sure you're here and ready for that. And with that, study hard, prepare well, and I hope you do well. Talk to you later.